Stevens Bakery has founded its marginal profit. Look at that. And it gives the cost. Do you have the book open? On page 388, it says total profit from marginal profit and it gives the C prime. Do you see the same thing I do? And on problem 9, it says total profit from marginal profit, but they give C prime. Anyway, so I'm going to change it to profit. So negative 0.12x plus 40. I think they mean cost, but where x is the number of wedding cakes produced. Find the total profit from producing 50 wedding cakes. Total profit from producing 50 wedding cakes. Okay, so this will be an approximation because I have not shown another way of determining the area. Basically, if you graph this profit function, the derivative, so the profit will be nothing else but the limit as n approaches infinity from the sum from I equals 1 through n from delta x times f of xi. We have to decide because it will be an approximation. We don't know how to determine this. We know how to determine delta x, 50 minus 0 divided by, and you tell me how many subintervals you want, how many you would like to work with. We may work, let's say, with 5 subintervals. So then delta x will be 10. And then we have to find either you're interested in the leftmost point, rightmost point, or midpoint. So this is the subinterval between 0 and 50. And we are dividing up into 5. 1, 2, 3, 4, 5. So this is 10, 20, 30, 40, and 50. And we want to use the leftmost point, the rightmost point, or the midpoint. Of course, the midpoint, it's fine, because I will use 5 and then 15 for the height, f of 5, f of 15, 25, 35, 45. So which one would you like to use? And then the next step will be to calculate the exact area, and I'll show you how. Right now, let's approximate it. So we want the leftmost point, rightmost point. So delta x is in front, or if you want to write it with a summation notation, that's even better. But let me write it first like this, just a couple. So f of, we want to stick with the leftmost point, rightmost point, or midpoint. Let's do the midpoint this time. F of 5 plus dot, 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 f of 45. So this is the sum, 10 multiplied by, what was the function? Negative 0.12x plus 40. This is the xi from I equals 1. How many? We have 5. So the sum from x equals 1 to 5. And now careful how you put it in, because I think that this time maybe I should distribute. I'm going to distribute. So I want negative 1.2x and plus 400. And close the parenthesis. It may drop my parentheses, but that's okay. So delta x times f of xi. So negative 1.2 times x plus 400. 1982. So that is the profit. using five subintervals and with the midpoint. This is not exact. And now finally, let's determine the exact. So the exact area under the graph on the interval a comma b, when the function is continuous, f of x continuous on the interval, is not only the limit of the Riemann sum from I equals 1 through n, from n approaching infinity, from delta x f of xi, but it's the same, as I promised, the stretched s from a to b, the same thing, but written as f of x dx. It's the exact same thing. This is called the definite integral. It is a number. And how it will be calculated. In our case, I'm coming back to this problem, 10 on 388. So, which is the profit that we are interested in. It will be the integral from 0 to 50 from the function. Now you notice that this is the dy that we talked about. This is the differential of y, right? Basically f prime of x dx. The function was negative 0.12x plus 40 times dx. The question is, how do we evaluate the definite integral? So I'll come back to this. It's called the fundamental theorem of calculus. It has two parts. Right now, we're going to use the part that teaches us how to determine the definite integral. It says f of x continuous on a comma b. Otherwise, it fails. It cannot be applied. The integral from a to b from f of x dx, which is a derivative, right? It's a differential, is, and you remember from the first thing we did today, here it is. The most general antiderivative evaluated between a and b. And this is calculated by applying or replacing x with the upper limit, lower limit, upper limit, lower limit. F of b minus f of a. This is fundamental theorem of calculus. One of the two parts. There is another part to it. This is the part that teaches us how to evaluate a definite integral. Finding the most general antiderivative of this function, and then evaluate it at the two limits. First, the upper, and then minus the lower. So, coming back to our problem, and now we will determine the exact profit. So, I have, which function prime is this? Negative 0.12 x squared over 2. I increase the power by 1 and I divide by that number. Plus, which function prime is 40? It must be 40x. Parentheses, a vertical bar from 0 to 50. At this time, I will plug in 50, and I should subtract when I plug in 0, but there is no need because 0, 0, I will have only 0. So then final answer will be, I will simplify, negative 0.06, 50 squared plus 40 times 50. Minus 0 because when I plug in 0, which I don't even need to write. Negative 0.06 times 50 squared and plus 40 times 50. It's 1850. And that's the exact. All the other numbers are either under or below, under or above. Any questions? And this is the exact.
I have one question.
Please.
So you know how from the beginning you said to like where to start from, like the left or the middle or the right?
Yes.
If we, let's say if we chose any of them, like let's say that we
They
chose
will
the
all
left.
be approximations.
Mm-hmm.
This is the exact.
Okay.
Anything else will be an approximation. Either the limit of the Riemann sum, which we cannot determine for this function, we cannot. We don't know how to determine this. Or the definite integral, which is so much easier. Anyway. Okay, let's look at another problem. And now I can finally look on page 390, because now we have all the information we need. So let's calculate just any integral you would like. I see all of them start at 0. I don't really like all of them starting at 0. So is there another example without starting it at all of them at 0? I can make one up. Doesn't matter. So let's go back to any of the functions that we looked at. So, oh, finally we can determine the area under x squared. I know it started at 0 because of for simplicity. So we know this. We found 3 values. We found the leftmost point with the leftmost point, with the rightmost point, and the midpoint. So one of them, if I remember correctly, was 1, the other one was 5, and the other one was 2.5. So let's see what is the exact area. Very easy. So the antiderivative is x to the third over 3. And all I have to do is plug in 2, and I get 8 over 3, minus when I plug in 0. So the area is 8 over 3. And 8 over 3 is what? It's 2.6. Right? 8 divided by 3. What is it? Yeah, 2.6666. So look at this. How close we were with the midpoint. Okay, any other integral? Let's do another. Let's say 36. It's the integral from 0 to 5, I believe. Yes, it's 5 from 2x plus 5 dx. Now we know how to find these integrals, definite integrals. There is another type of integral for next time. So this is 2x squared over 2 plus 5x, evaluated from 0 to 5. So I evaluate for 5, so I get 25, plus another 25, minus when I evaluate for 0, that's 0, so the answer is 15. I don't see anything else here. Let me see if I can find another interesting example before we look at properties, but next time, I promise. Not now. I know I have 5 minutes left, so let me find. Okay, so I jumped ahead to, let's say, 47 as the last problem for today, unless you have questions for me, of course. So 47 on page 402. It's the integral from, because I want you to see -2 to 5 from 2x squared minus 3x and plus 7 dx. There is no integral without dx, ever. The function can be 1, can be 3. I'll show you properties of the definite integral next time. But as long as there is an integral symbol, there must be a dx or dt or dy, whatever. The most general antiderivative is 2x to the third over 3 minus 3x squared over 2 plus 7x. There's nothing I can simplify. It's an ugly situation. I will plug in 5. So 2/3 times 5 to the third, 125, minus 3/2 times 5 squared, which is 25, 25 plus 35, minus, I don't want to forget to distribute a negative sign. I plug in -2. So I have 2/3, but times -8. And then minus 3/2 and times 4. And finally, minus 14. It's an ugly calculation. Let's see. I don't want to hold you. I'm just going to stop in a couple of minutes, whatever I can do here. So 125 times 2 is 250 over 3. This will be 75 over 2 plus 35. This will be positive 16 divided by 3. This simplifies, it's -6 but positive 6, and then minus 14, but it's positive 14. Okay, let's see. This is 20 and this is 55, so plus 55. This will be 266 over 3, and then minus 72 over 2. The least common denominator is 6. This needs a 2, this needs a 3, and this needs a 6. Okay, 266 times 2 minus 3 times 72 and plus 55 times 6. I got 646. I will simplify by 2 and get 323 over 3. Any questions? Any questions? Any questions?